Hello there, this is Craig Hain or Dr. Dell talking again, and this is going to be a discussion of the interlude that I called Archimedes' Tombstone that you came to in the teaching math book that you're reading. And I wanted to tell you what it is because I think it's very interesting. And if you are a teacher, this might be something you would find interesting and you could use. Of course, Archimedes was the greatest Greek mathematician, really the greatest mathematician of antiquity as far as we know. And he made a lot of profound discoveries, not only in mathematics, but in science in general. And of course, he was the first of the Greeks to actually be able to prove or demonstrate that the area of a circle was what we call pi r squared, but c divided by 2, circumference divided by 2 times diameter divided by 2, which then little algebra shows you that's pi r squared. Well, that was quite an amazing thing, but he made a more profound discovery that he wanted inscribed on his tombstone, according to things that I've read. And so it turns out that that is a very good memory device for something that we can use in the Practical Math Foundation course. Because what he discovered was that the volume and the surface area both of a sphere are exactly 2/3 of the volume and surface area of a cylinder that would circumscribe the sphere. Now, it's very easy to derive the formula for the volume and the surface area of a cylinder, so that makes it then easy to derive the formula for a sphere. And one of the things that I do in the foundation course that the students learn is I emphasize the fact it's really important to understand formulas as much as you're able to, and hopefully be able to derive them as opposed to just remember them. And so this is an example of a way to derive this formula, given what Archimedes learned. And it shows that there's a special relationship between the cylinder and the sphere. It's a good mnemonic device. And it also begins to give these students a sense of history and sort of the profundity of what our ancestors went through. Plus, I think it's just plain old fun. So I would definitely encourage you to do that. In the foundation book, this is something we cover way back in geometry in G18, the volume of a sphere. Now, I might tell you in G17, we talk about the surface area of a sphere, and I actually discovered an easier way for me to remember it than Archimedes' tombstone. So I explained that here, but then I also explain Archimedes' tombstone because I do not have an easier way to remember the volume, and so that's how that works. Now, essentially, that's discussed here. You can simply yourself take a sphere of radius r, inscribe a cylinder around it, and just go through and figure out first its total surface area, and that will turn out to be 6 pi r squared. And then you take 2/3 of that, and that'll get you the area, surface area of the sphere. And then the volume will turn out to be, well, what does it turn out to be? Let's see this. Let's see. Let's take the cylinder. You've got pi r squared is the area of the base. The height is 2 times r, so that would be 2 pi r cubed would be the cylinder. Take 2/3 of that, that'd be 4/3 pi r cubed. So that's how you remember that. I did that kind of in my head in a hurry. We actually do that then in several exercises in the exercise book. And well, we don't prove it. It's very hard to prove, by the way. It's not a trivial thing. In fact, George Simmons proves that in his wonderful book that I keep referring to that we use in Tier 3 and in Tier 4. And I always thought, frankly, that you couldn't prove that with anything less than calculus. And that's how I learned it when I was a student. But George actually gives us a marvelous proof using what's called Cavalari's principle. And it's essentially bringing the ideas of calculus into play, but with none of the machinery of calculus, if you just accept this principle. And then from that, he very cleverly derives first the volume formula for the sphere, and then he uses that to derive the surface area. So actually, on about 3 or 4 pages here, he proves these two formulas. Now, it is so subtle that we go over in Tier 3, but we don't expect a student to really fully master it and understand it till Tier 4. It's that deep. George does a lot of things in this book that, quite frankly, We do not emphasize in Tier 3. We wait till we go over the book for the second time in Tier 4, and then we make sure that we go over the deeper the proofs that we didn't cover in Tier 3. Of course, we do more in Tier 4 than just go through this book again. We now introduce other things that are appropriate for pre-calculus math, and in fact, I'm going to talk to you about a couple of them on the next two interludes that involve complex numbers. But I wanted to tell you about this today. This Archimedes tombstone is a very interesting idea. It accomplishes a lot of things. And of course, one of the things we're always wanting to do is to get the students to look ahead. And so we give them these formulas, and the way to remember them, and even a way to derive it if you accept the 2/3 ratio that Archimedes discovered. But of course, that's not a proof. And then we point out to them if they want a proof, they're going to get that in a later treatment in math, which would be Tier 3. So those students that want to go beyond practical math have that to look forward to. And if students are only interested in practical math, they probably don't really care that much about that proof anyway. So this is Dr. Dell signing off, and I will see you on the next interlude. Bye-bye.